Okay, for this problem, 14.37 is asking a 155 grams glider on a horizontal frictionless air track is attached to a fixed ideal spring with force constant 170 newtons per meter. At the instant you make measurements on the glider, it is moving 0.850 meters per second and is 2 centimeters from its equilibrium point. So first, you have to write down all the information. I got that the mass is 155 grams. That is also 155 kilograms. Then we have that the force constant, the K, is equal to 170 newtons per meter, and the velocity is 0.850 meters per second, and we have that the X is 2 centimeters, which is also equal to 2 meters, 0.02 meters. So now we have to use the energy of the system formulas. So I put first the working energy formula and also the oscillation formula right here. So now we just have to plug in the numbers. So we have 1/2 times the 0.55 kilograms times the velocity squared plus the 1/2 times the K, which is 170, times the 2 centimeters in meters, so 0.02 squared, and that's gonna give us the joules. 9.00 times 10 to the negative 2 joules. So now we have to use the energy equals 1/2 Ka2, which you can get using the oscillation formulas. So if we need to get the amplitude, so we just have to solve for that, and that's going to give us 2e square root 2e over k. So now we just have to plug the information we got. So we know the energy is that, so 2 times 9.00 times 10 to the negative 2 over 170, and that's going to give us 3.25 centimeters. And that's the answer for part A. For part B, we're gonna use it's asking use the energy conservation to find the maximum speed of the glider. So here we know that energy is equals to half mv squared. So we're gonna use that formula. We just have to solve for the velocity. B max equal to 2e over m. So that's gonna be the 2 times the energy that we got. The first thing we did, 9.00 times 10 to the negative 2 over the mass in kilograms. And that's going to be 1.08 meters per second. That's your max velocity. And for the final part is asking what is the angular frequency of the oscillations. So we're just going to use the oscillation formula, which is that one. And then we just plug the numbers that we already got since the beginning. So 170 over the mass in kilograms, 0.55, so that's going to be 33.1 radians over seconds. And that's it.